and then share the homework from last night. Okay, so here are the answers. I did upload this answer key to Google Classroom for you. So you should hopefully have been able to check your answers last night. If you noticed that that was out there, you should be checking Google Classroom daily. It sends you a Google Classroom reminder. I put the video out there. So there's lots of good stuff out there for you. Then I can't send it from, I know how I can do it. I can go and call up Chapter 9 material. Here we go. And okay, Shay, I'm sending them now. All right, so questions on any of the problems so far up here? Do you have any issues with them identifying or anything like that? How about any of these? Let me move this out of the way. There we go. All right, any questions on any of that stuff? Anything not making sense? Anything I can help you with? Which one? Number 10? Okay. So I'm going to show you some tricks when we get to these. My main trick when I'm doing this is look at the carbon, okay? If the carbon is an even number, I tell you to put a 2 out front here, okay? Just start with that. 95% of the time, this will work, okay? And the 5% that it doesn't work perfectly, all you have to do is go back and reduce. So that's the only thing that it's going to mess up for you. Okay, so you go through, you start with a 2 here, and then once you have that 2 in place, you balance in that same order of appearance here. Okay, so you're going to balance your carbons on the other side. So 2 times 4 is 8. So you start with that. Then you balance your hydrogens. Well, 2 times 10 is the same as 10 times 2. So you've got that balanced. Then you finish with your oxygens, because remember your singletons, the things that are by themselves that aren't with other different elements, you hold those off to the end. So count up your oxygens now. 8 times 2 is 16. And then here you've got 10. That's a total of 26. So over here you need 26. That makes sense? So like I said, if the carbon is even, put a 2 here. Then balance your carbons. Then balance your hydrogens. Then balance your oxygen. Sometimes when you get done, everything will be divisible by 2. But I would say that that's only maybe 5% of the time. 95% of the time, this is going to be your sure bet. If this carbon is an odd number, then just start balancing your carbon, hydrogen, oxygen in that order. Those can get a little cumbersome if you don't use that trick. If you use the trick, then you're just like, this is easy. All right. Next page then. Let me rotate that guy. Did you have more? No. No, that page was rotated. Never mind. I got to go back up here. I got to go over to the side. That's what I have to do. Sorry about that. I hope I'm not making you kind of car sick here with this. All right. I goofed on your number 11. I forgot to erase some stuff. So I don't know. This is what it should have looked like. I know now after talking to First Hour, or First Hour talking to me. Anybody from First Hour? No. First Hour yelling at, no, they didn't. They were pretty good, but they can be brutally honest in here sometimes. So I apologize for number 11. Any questions on any of the other ones here? Any other? I think there was another goof down maybe here. So number 15 was another goof of mine. I thought I had changed it on the original. I'm sorry, you guys. I really did. I thought I had changed that before I printed it. But alas, Lippy has managed to disappoint you once again. All right. There's the rest of that sheet. Did I cut anybody off by moving that? Alyssa, did you get yours done? Alex?
Yep.
Done? Brendan? Done? Done? Drayton? No? Yep. Yep. All done? All done? All done. Okay. All right. Okay, so we're going to start in then with the next section. And Shay, did you get that packet yet? The email?
Yes.
Okay, so the first thing that I'm going to show is the first page of that. It looks like this. So that's where we're going to be talking, and we're actually going to start down here in this section called decomposition. You guys need this sheet, okay? This sheet will be used for any test or quiz in here. You do not need to memorize it. You just need to know how to use it. I don't know if you heard that, Shay. This sheet that I'm handing out to them that you can see on the screen right now, it will be used for any test or quiz. So you don't need to memorize it. You just need to know how to use it. And I'm going to start by showing you how to do that today. Okay? All right. So the first thing we're going to do is I'm going to go down to your homework for tonight, and I'm going to start doing some of the problems for you. And then give you kind of some hints along the way. All right, so the first example on your sheet here is lithium chlorate. So you should be comfortable at this point being able to write the formula for lithium chlorate. So using your periodic table, figure out how to write lithium chlorate. So lithium is Li, figure out what chlorate is, bring them together, make a compound. Go. All right. So decomposition is the easiest one to identify because with decomposition, you start out with one reactant. We don't have a plus sign here and something else. So this is easy to figure out what it is. Now, there are several different types of decomposition that you can go with depending on what your starting substance is. So the first example would just be a single thing here, 2 elements, and they're going to break down into the individual elements. Be careful when you do this, because these things, your metal is not going to have a subscript, no matter if it does over here or not. So for example, if we had aluminum oxide, when we go over here, that aluminum is not going to have a subscript. The oxygen will. It's going to have a 2. Why? It's diatomic. It's one of your Brinkelhoffs. Okay? But this doesn't. Do not go over to your reactant side. Do not go over here to get your subscripts for this side. Do not do that. Ever, ever, ever. Okay? And then you have to go through and balance this. So here's another example of that. Electrolysis is just a fancy word for saying that we're going to split some water up. Decomposition of a metallic chlorate is going to give you your metal chloride and oxygen, and we give you an example down here. Again, this sheet will be for every test and every quiz. Metallic carbonate gives you a metal oxide, so whatever the metal was over here, you bring it over here, and you put oxygen with it. Make sure that your charge is balanced, right? And then it's going to also give you CO2. And then metallic hydroxide. So you've got your metal and your hydroxide here. That's going to give you a metal oxide. So whatever your metal is, plus oxygen. And then it's also going to give you water. And then this is decomposition of an acid. Okay, so let's go down and do some of these. You need to try to identify out of those decomposition reactions, which one is this? Which sample is this? This A through F that I just showed you on your reaction type sheet. Which one is this? Which is option C. Okay. And it tells us that this is going to form, and you don't have to write this part down because you have your sheet, but I'm just going to do it so that I don't have to bop back and forth between the sheets. So this is going to give us a metal chloride. And it's also going to give us oxygen. Okay. So we need to come over here and figure out what our metal is. What is our metal on this side? Lithium. And we're going to put that together with chlorine. And then that's also going to give us O2. Now, I need to go back and I need to check my charges on this. This is I'm not going to look over here. Don't do it. You check your charges on this side. Check your privilege, check your charges. Okay? Check your charges. +1, -1, we're done with that. Now we need to go through and we need to balance this equation the way I taught you yesterday. So on this side, I have 1 lithium, 1 chlorine. So that balances, but my oxygens are out of whack. So the saying is, even and odd, what do I do? Even and odd, double the odd. So I'm going to put a 2 out here. That not only affects my lithium, it affects my chlorine too. So I'm going to put a 2 here to take care of those. What does it do to my oxygen? How many do I have? 6 over here. I need 6 here. What do I put for my coefficient? 3. Okay. Questions on number 1. All we're going to be doing is giving you your reactants. So you have to know how to deal with this, but you're going to have that sheet to help you. Okay. All right. Next one is aluminum hydroxide. Write the formula for that. So aluminum hydroxide should be AlOH3. Did you get that formula written correctly? Now we've got to figure out what this is going to make. So if we look at our reaction type sheet for decomposition, which option is that? A through F, which option? E. Okay. And that tells us that we're going to make a metal oxide and what else? H2O, water. Okay. All right. So what is my metal on this side? Aluminum. And I'm going to bring that together with oxygen. And then I'm going to have my water. I need to check my charges on this, though. Do not look over here for charges. This is a +3. This is a minus. Oh, hello. What happened there? This is a -2. Okay. So I need 2 of these for every 3 of these to get that to balance my charges out. Do you see that we cannot look over here for those subscripts? If you do, you will get it wrong most of the time. That is one of the biggest things that people make mistakes on. The other thing that people will make mistakes on is that they don't list their metal first. So they'll write this OAL, and then they might have it balanced, but it's still wrong because you don't write the O first. Okay? Good? Make sense? All right. So once I have that done, now I'm going to balance my equation. I have 2 aluminums over here, so I need 2 over here. I'm going to start there. That gives me how many oxygens now? 6 oxygens, because 2 times 3 times 1 is 6. So I need 6 oxygens over here. Okay, so if I need 6 oxygens over here, I've got 3 already. I need 3 more, so I'm going to put a 3 out here. Good learn. There we go. Now I've got 6 oxygens. I've got 3 plus 3 times 1 is 3. That makes a total of 6. And then my hydrogens, how many do I have? 6. So my hydrogens are now balanced as well. All right. Potassium carbonate then. Write the formula for potassium carbonate. Okay. All right. What does it tell me? Which reaction is this? A through F, which reaction? D. It tells me that I'm going to make a metal oxide. And I'm also going to make CO2. All right. So my metal on this side is what? Potassium. So I'm going to make potassium oxide. Again, I do not look over here for my charges. This is a +1. This is a -2. So how many of these do I need to balance that out? 2. And then I'm also going to have CO2 here as well. All right, now we check our amounts. I have 2 potassiums. I have 1 carbon, and I have 3 oxygens. Over here, I've got 1 plus 2 is 3. So that guy's already balanced. We don't have to do anything with coefficients. All right, any questions on 1 through 10? All right, so that takes care of decomposition. Now we're going to look at synthesis. So with synthesis, that's at the top of your reaction type sheet. Right here. You can have it where you've got two elements that are coming together to make one. So if you have an element and an element, it can only form a compound. Okay? So one element plus one element equals one compound. Metallic oxide then and water is going to be synthesis, and it's going to form a metallic hydroxide. And then occasionally, rarely though, you'll see these two, where you've got a non-metallic oxide and water forming an acid, or a metallic oxide and a non-metallic oxide that's going to form salt. All right, the last two are pretty rare on there though. So let's go through the first couple, do a couple examples there. All right, sodium and oxygen then. We've got sodium. We have oxygen. We're going to form sodium oxide. Now, this is where people will bring over subscripts and they'll just put a 2 down here and not pay attention. Don't do that. Go back to your periodic table and check your charges. So I need actually 2 of these for every one of these. But that's where people will go wrong a lot. So be careful with that. Now I need to get this guy to balance. So even and odd, I do what? It's the saying, even and odd. What do I do? Double the odd. Remember that? Even and odd, double the odd. So my oxygens are balanced now, but my sodiums are not. So if I put a 4 there, I've got that balanced. Okay. And then we're going to do number 5 here as well. Okay. So number 5, I've got calcium oxide and I've got water. Reaction type sheet, letter B, yes, tells us that we're going to form what here? A metal hydroxide. What's my metal? Calcium. I'm going to bring that together with hydroxide. Don't look over here for subscripts, because if you write it like this, it's going to be wrong. Nothing has really subscripts over there. If I wrote it and just brought my subscripts over, it would be wrong. I've got to put a, this is a +2 and a -1. So I need how many of these? 2. If I put a 2 down here, is that right? No. It has to apply to the whole hydroxide. So I've got to put that in parentheses. And now I'm looking good. Then I'm going to check and see if this is balanced. So on this side, I have 1 calcium. I have 1 over here. How many oxygens do I have on this side? 2. How many do I have on this side? 2. So that is balanced. And how about my hydrogens? I've got 2 over here. I've got 2 here. So we are balanced. Okay. Occasionally, they'll balance themselves for you. That's kind of nice. So you have the rest of this page. And then you've got 8 problems over here that are done like you did yesterday, just to keep you in practice for writing formulas. And hopefully I don't have a lot of errors there. But we'll see. So let's see, you get out it. 33. You should be able to get a good portion of these done. The answer keys are online, but I also have them in here, so you can come and check your work as you're working through this today as well. Okay. All right. All right. So there you go. Yeah, just sign out. Shay, if you want to head out and go and work on some of the stuff that you missed yesterday, let's